This is a video looking at the worked solutions for the WJEC Maths exam Unit 2, first taken on the 6th of June 2019. In this video I'll be using an online scientific calculator. You will need a calculator for this calculator allowed exam. Question 2. Let me get my pen again. Question 2. Part A. Find the value of 5f plus 7g when f is equal to 3.8 and g is equal to minus 2.6. So I'm going to substitute those values into the equation. 5 times 3.8 plus 7g, so 7 times, and remember it's minus 2.6. So I'm going to do the first bit, 5 times 3.8. Go over to my calculator. 5 times 3.8 is equal to 19. Plus 7 times minus 2.6, let's clear it. So 7 times minus 2.6 is equal to minus 18.2. So plus and minus together turns to a minus. So 19 minus 18.2. So 19 minus 18.2. I don't need the calculator for this. I know the answer is 0.8. Part B asks us to solve the equation, giving our answer correct to one decimal place. Now, solving equations means finding x is equal to something. So you need to get x on its own. So let's take the equation. So the first thing I'm going to do is get rid of that 4. I can get rid of that 4 by adding 4 to both sides. 7x minus 4 plus 4 is equal to 12, and then add the 4 that we added on the other side. Those two are 0, so that leaves to 7x is equal to 12 and 4, which is 16. Now I'm going to divide both sides by that 7 to get rid of the 7. So 7x over 7 is equal to 16 over 7. So those cancel each other out, meaning x is equal to 16 over 7, which is 16 divided by 7. So I need to go back to my calculator. 16 divided by 7 equals 2.2857 and so on. But I do want my answer correct to one decimal place. So it's going to be 2.3 because the 8 that I'm getting rid of here means that I have to round that 2 up to 3. So the answer is going to be 2.3. And then I always put just correct to one decimal place. Question 3. Get my pen. So question 3. A. Circle the longest time period from the list given below. Well, the list tells us a series of minutes and a series of hours. In order to compare these and find the longest time period, we have to change them all to either minutes or hours. I'm actually going to change them all to minutes. So 180 minutes is already converted. 4.5 hours, well, there's 60 minutes in an hour, so 4 times 60 is 240. Half an hour is 30 minutes, so I'm going to add on that 30, and that gives us 270 minutes. 4 hours, 45 minutes, well, 4 hours is 240 minutes, plus the 45 minutes is 285 minutes. 4 1/4 hours is 240 minutes. A quarter of an hour is 15 minutes. So that's 255 minutes. A sixth of a day. I think is 4 hours, which is 24 hours divided by 6. So it's 4 hours, which is of course 240 minutes. Now, if we look at all our minutes, we can easily see that 285 is the longest time period. So I'll just simply circle that one. Part B, circle the longest distance from the list given below. So again, we'll have to change them all to the same units. And here I'm going to change them all to centimetres. So this first one, 30,000 millimetres. Well, I know there's 10 millimetres in a centimetres. So if I divide that 30,000 by 10, it gives me 3,000. That's 3,000 centimetres. 250 metres. Well, I know there's 100 centimetres in each metre. So if I multiply the 250 by 100, I get 25000, which is 25,000 centimetres. 2 kilometres and 70 metres. I know that 2 kilometres, there are 1,000 metres in a kilometres. So 2 kilometres is 2,000 kilometres and 70 metres. 2,000 kilometres and 70 metres. Multiply that by 100 to get it to centimetres, and that gives us 207,000, which is 207,000 centimetres. 4,000 centimetres, I'll leave it. 2.4 kilometres, which is 2,400 metres. Multiply by 100 to get it to centimetres, which is 240,000, which is 240,000 centimetres. So the longest distance is 2.4 kilometres, so I'll circle that one. Part C asks us to circle either true or false, and it gives us a list of distances. Some are imperial and some are metric, and you need to be able to convert between metric and imperial. Now, the first one, 7 kilometres is less than 5 miles. Well, I know that 1 mile is the same as 1.6 kilometres. So 5 miles is 5 times 1.6 kilometres. Pop that into the calculator. 5 times 1.6, which is equal to 8 miles. So the statement 7 kilometres is less than 5 miles is actually true. 1 kilogram is less than 2.2 pounds. Well, 2.2 pounds, I know, is equal to 1 kilogram. You have to learn these conversions. So 1 kilogram is less than 2 pounds is false, because 1 kilogram is actually 2.2 pounds. 1 litre is less than a pint. Is that true or false? Well, I know that 1 pint is equal to 0.47 of a litre. So 1 litre is less than 1 pint is false. 8 litres is less than 9,000 centimetres squared. Well, I know that 1 litre is the same as 1,000 centimetres cubed. I should have said cubed. So 8 litres is less than 900 centimetres cubed is actually false. Question 4. Katrin makes the following statement. If you double the length of each side of a rectangle, you will double its perimeter and also double its area. Is Katrin correct? And she'll clearly use an example how you came to your decision. Okay, first thing I'm going to do is sketch a rectangle. I'm going to call the length of its side A and the width B. So I'm going to first work out the area of this rectangle. And the area of any rectangle is simply the length times the width. So it's A times B. If I double the area, I simply multiply AB times 2, so it's 2AB. If I now work out the perimeter, now the perimeter is A plus B plus A plus B. So perimeter, of course, is all the way around. So that leaves me with 2A plus 2b. Now, if I double that, that gives me 4a plus 4b, which is not the same as the area, double the area, which is 2ab. So I can quite happily say that Catherine is not correct in a statement. Okay. Okay, question 5. Before I even start reading question 5, I've looked at the marks and seen that we gain 2 extra marks for organisation, communication and writing. So I've got to make sure that the answer to this question is laid out very clearly for anybody to follow. I've also got to make sure I use the units throughout. So let's look at the question. 18% of 256 is shared in the ratio of 2 to 1. Calculate the value of the largest share and give my answer to the nearest 10p. Well, the first thing I'm going to do is find out what 18% of 256 is. So I have to write that down. 18% of 256. Various ways of doing this, but I just simply use the calculation. 18 over 100 multiplied by 256. If I put that into the calculator, I'd get the answer of £46.08. So that's the first part. So this £46.08 is shared in the ratio of 2 to 1. So if it's shared in the ratio of 2 to 1, that means there are 3 parts. So if I split 46.08 into 3 parts, and you can see I'm writing everything down here because it's an OCW question. Split 46.08 into 3, which is simply 46.08 divided by 3. 1 part is equal to £15.36. Again, I've used my calculator for that. But if it's split into the ratio of 2 to 1, that means 2 parts. So twice times £15.36 to 1 part, which is 1 times 15.36, gives us 30.72 to £15.36. I'm just going to make sure I put my units in, otherwise I'll lose marks. So the larger part, the larger share is 30.72, so I'll write that down. So the larger share is £30.72. But looking again at the question, it wants us to give the answer to the nearest 10p. So the nearest 10p, because the answer is below 0.74, the answer would be £30.70, and in brackets, so to the nearest 10p. Again, I've rounded down because this number is below 4. And that's the answer to the question. Okay, question 6 asks us to factorise 7a plus 11a. Now, factorise means to put some brackets in the answer. We look at each group of digits there and try and find the common factors that appear in both. Well, I can see a appears in both, so I'll take that outside the brackets. So a times something gives me 7a, so it's 7b, and a times something gives me 11a, and so that's 11. And that's you factorised 7ab plus 11a. B asks us to factorise x squared minus 8. So I'm going to put my brackets in first. Now, what's the common factor of x squared? What appears in x squared and minus 8x? Well, of course, x does. So I've taken x outside the brackets, and then I'm going to find the missing numbers. X times something gives me x squared. Well, x times x gives me x squared. X times something gives me minus 8x. Well, it's minus 8. And then finally, part C, expand 4y brackets 2 minus 3y. Expand is the opposite of factorize and just means getting rid of the brackets. So if we remember there's an invisible multiply between the 4y and the brackets, we can see that the first set of numbers is going to be 4y times 2, which is 8y, and then 4y times minus 3y, so that's minus 12y squared. And that's that expression expanded. Question 7. Question 7 tells us that the diagram shows us two congruent triangles. Now, congruent means the same. It just means that they have sides of the same length. They can be reflections of each other, but the shapes are essentially exactly the same side lengths, the same angles, etc. It tells us that the coordinates of each vertex are shown. A vertex is where 2 points meet. So you've got these 3 here a vertex, and these 3 here a vertex. And they've drawn these two congruent triangles on a graph. It asks us to find the values of A and B. So first of all, A, it wants us to find the value of, and B. These are all coordinates. But we know the relationship between these two vertex. So to find the x coordinate of the first vertex, we take 8, the x value in the first vertex, minus 1, the x value in the second one. So it's 8 minus 1, which is 8 plus 1, which is 9. So the relationship of the x value of these 2 points is that the x value has moved 9 places to the left. Now the relationship of the y value of the same coordinates are 15 minus 5, which is 10. That means the y value has moved 10 places down. So because we know this, we can apply them to these values here. So if we take these first coordinates 3, 2, they're related to those two in the same way. So the x coordinate is 3, and then I'm going to take 9 away because it's moved 9 to the left. And I found that out because of this value. So 3 minus 9 is minus 6. So that's A. The B coordinate, which is y, same process. We take the y coordinate of 5. We take 10 away because it's going to move down 10. 5 minus 10, which is equal to minus 5. So that's the B coordinate. So A here is minus 6, and B is minus 5. So let's put them in. A minus 6, B minus 5, and that's the question answered. Part B of this question asks us to draw an enlargement of the rectangle below using a scale factor of 3 and a centre of 1, 2. Now I know enlargement means we're going to draw a shape that's bigger than the existing shape. Because we're using a scale factor of 3, the base of the existing shape is 1. The base of the enlargement will be 3 times 1, which is 3. The length of the side here is 2. The length of the new side will be 3 times 2, which is 6. But we have to draw it in a specific location. And if we look to the centre of enlargement at 1, 2, So the x-coordinate is 1 and 2. This is the centre of enlargement. We look at this vertex here and measure the distance from the centre of enlargement to the new vertex, which is 1 across and 1 up. Increase it by a scale factor of 3. So that means it's 3 across and 3 up. So that point is going to move to there in the new enlargement. I then draw the base of my rectangle, which is going to be 3 times as long as the original one. So it's 1 times 3, which is 3. It's going to be 3 times as high. So it's too high at the moment. So that means it's going to be 6. And then I join my rectangle carefully. Obviously in the exam I'd use a ruler, but I can't with my graphics tablet. And that's the enlargement with a scale factor of 3 and a centre of 1, 2. So here we have question 8. Question 8 tells us that Alison and Sarfraz play a game. They each have a different bag of cards. Alison has the following cards in her bag, and you see the word Carnarvon. Sarfraz has the following cards in his bag, and you can see Aber. The question tells us that they each take a card at random from their own bag. They make a note of the letter and return the card to the bag. They do this 100 times. Who do you think is more likely to choose the letter R more often? So first of all, I'm going to look at Alison. And I'm going to work out the probability of her choosing an R. So the probability is the number of R is the number of successful outcomes. So how many R's are there? Well, there are 2 in the word Carnarvon out of a possible 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it's 2 out of 10. But if she does that 100 times, she takes a card out 100 times, we expect her to get 100 times 2 out of 10 R's, which is 200 over 10, which is 20. So I expect her to get 20 R's. If we look now at Sarfraz, the probability of him getting an R is the number of successful outcomes. So the number of R's in Aber, well, there's only 1 out of a possible 4 letters. Now, if he takes 100 turns, if you like, or if he chooses 100 times, he would get 1 over 4 multiplied by 100 number of R's. And that means he would get 25 R's. So in answer to the question, who do you think is likely to choose the letter R more often, we'd have to say Sarfraz, because he will get 25 R's as opposed to 20 R's. And this is explanation enough for the examiner. And we move on to question 9. It asks us to write down the nth term of the following sequence. So looking at this sequence, I can see that the difference between each of the numbers in the sequence is that you have to add 3 to get to the next number. So when working out the nth term, I know because you have to add 3, the first part of the nth term is going to be 3n. But if I try that with the number 1, when n is 1, 3 times n is 3. I have to add 5 to get it to be 8. So what I'm suggesting here is that the nth term is 3n plus 5. I'm going to test it with the number 14 to see if it works. Now the number 14 is the third in the sequence. So n would be 3. So 3 times 3 is 9, plus 5 is 14. So it works. So I'm happy with that answer for the nth term. Part B asks us to make t the subject of the formula. That means we want the answer to be t is equal to something. That's what makes t the subject means. It's t is equal to something. So looking at the equation, r is equal to 3t minus 8. Now to get t on its own, there's a couple of steps. The first thing I'm going to do is add 8 to each side to get rid of that 8. So I'm going to put add 8 to each side. So that's r plus 8 is equal to 3t minus 8 plus 8. So those cancel each other out. And that leaves us with 3t is equal to r plus 8. Now I'm going to get rid of that 3 by dividing both sides by 3. So r plus 8 divided by 3 is equal to 3t divided by 3. Those cancel each other out, leaving us t on its own. So t is equal to r plus 8 over 3, which is the answer to that question. Part C tells us that a rectangle has length x plus 5 and width 2x minus 3 centimetres. It tells us its perimeter is 46 centimetres and asks us to calculate the value of x. Well, as ever, I'm just going to start with a little sketch of a rectangle. I know that its width is 2x minus 3. I know that its length is x plus 5. I know that the word perimeter means the length all the way round the rectangle. So the perimeter of this rectangle is x plus 5, that first length, plus 2x minus 3, the width. Then I'm going to calculate this length, which is the same as x plus 5. So it's plus x plus 5. And then the final width, which is 2x minus 3. And I know that is equal to 46 because the question tells me so. So now I'm going to simplify. How many x's have I got? I've got 1 and 2, which is 3, 4, 5, 6. So 6x. And I'm going to add up my digits now. Plus 5 minus 3 takes me to 2. Plus 5 is 7, minus 3 is 4. So 6x plus 4 is equal to 46. Now to find x, I've got to get x on its own. So the first thing I'm going to do is get rid of that 4. So I'm going to take 4 away from each side. So it's 6x plus 4 minus 4 is equal to 46 minus 4. Now they cancel each other out, meaning that 6x, let me get rid of that. 6x is equal to 42. I need to get rid of that 6, so I'm going to divide both sides by the 6. So 6x divided by 6 is equal to 42 divided by 6. They cancel each other out. 42 divided by 6 is 7, so we can see that x is equal to 7. And that's the answer to the question. Now we come to question 10. Is it possible to draw a right-angled triangle with the measurements shown below? You must use calculations, not a scale drawing, to support your answer and show all your working. Well, if this were a right-angled triangle, with the right angle being there, then we can use Pythagoras, because if you remember Pythagoras, the theory, if that's the hypotenuse, and that's A and that's B, the hypotenuse squared is equal to A squared plus B squared. So my strategy for this question is to work out the value of A squared and B squared, and if it's the same as that value, then we can say it's a right-angled triangle. So 12.8 squared plus 22.7 squared, and I will need my calculator for this. So 12.8 squared plus 22.7 squared is equal to, from my calculator, 679.13. Now let's find the square root of this. because if the square root of this is equal to 25.6, then we can say that the triangle is right angled. So the square root of 679.13, and again, using our calculator, use the square root button. Sorry, I'll just clear it. So the square root button of 679.13 is equal to 26.06 and lots of other digits, which is not 25.6. So this triangle is not right angled. Okay, question 11 tells us about Venn diagrams, and you need to learn the notification around Venn diagrams. This symbol here means intersection, and this symbol here means union. This little symbol at the top of a letter, say A, means not A. So you need to learn these. So first part of the question, which of the following sets represents the shaded area in the Venn diagram above? So this shaded area here is the intersection between A and B. So if we look at the options, and here we have A and B, A intersection B. That's the only one that'll fit. If we go to part B, it asks us which of the following sets represents the shaded area. So I can see that it's basically everything that's not in B. So everything that's not in B is represented by this symbol here. And that's the answer to the question. Question 12. Look at the following set of four numbers, 5, 8, 10, and 13. Find another set of four numbers so that the range is increased by 2, the mean remains the same, and the median is decreased by 1. Well, if we look at this first set of four numbers, and if we look at the range first, so if we look at the original four numbers, the range is the biggest number take away the smallest number, which is 13 take away 5, which is 8. Now, the first clue tells us that the range of the new set, I'm going to put new set, has increased by 2, so the range will be 10 of the new set. So the difference between the largest and the smallest in the new set of four numbers will be 10. The second clue tells us that the mean remains the same between the two numbers, between the two sets. So firstly, I work out the mean of the old set, which is where you add up the four numbers and divide by 4. So the old mean is 5 and 8 is 13, add 10 is 23, add 13 is 36, divide that by 4 and it's 9. So the old mean is 9, so that means the new mean is 9. And then the final clue is about the median. It tells us that the median of the new set will have decreased by 1. The median of the old set is the middle number. Now, we haven't got a middle number, so we have to add up the two numbers on either side and divide by 2. So 18 divided by 2 is 9. So the median of the old set is 9, and the median of the new set is actually going to be 8. Now, the final clue is it says you may use some of the numbers from the original set, but not exactly the same four numbers. Now, there are quite a few combinations that you could use. If I start with the number 5 as my smallest number in the new set, the largest number in the new set is going to have to be 10 bigger than 5, so it's going to have to be 15. So I've got my largest and my smallest number with a difference of 10. Now, if we look at the mean's going to be the same. That means all 4 numbers have to add to 36. Finally, these 2 numbers in the centre have to give us a median of 8. So when you add them and divide by 2, they've got to give you 8. Now, the only number divided by 2 which gives 8 is 16. So 2 numbers here that add to 16. Well, I could have 8 and 8. I couldn't have any number less than 5 because 5 has to be my smallest number in this range. And I couldn't have any number bigger than 15. But I could have 6 and 10. I could have 9 and 9. No, 9 and 7. So there's loads of different combinations. But I'm going to stick with 5, 8, 8, 15. Okay, question 13. Question 13 tells us that a company has 3 sites based in Wales: Carno, Holyhead and Porth. The pie charts below show the distribution of 128 female staff, which is this pie chart, and 72 male staff, which is this pie chart. It tells us that a person chosen at random from the company's 2,200 staff members, what is the probability that this person works at the Porth site? So it doesn't matter whether they're male or female. So I'm going to draw a little table to help me with this, and I'm going to write Carno, Porth and Holyhead. I'm going to work out the number of females and males at each site, and then I'm going to work out the probability, add the ones from Porth and work out the probability of Porth. So the number of females in Carno is a quarter of the 126, because I think that, 128. So the number of females is a quarter of 128, which is 32. The number of females at Porth is again a quarter, because it's a quarter of the pie chart. So a quarter of 128, which is equal to 32. The number of females at Holyhead is half of the 128. Half of the 128, which is 64. And as a check, if I add those 3 numbers together, they come to 128, which is the number of females. If we now go on to the number of males, it's a little more tricky, but the only one I'm really interested in is the number of males at Porth. Now, the number of males at Porth, we've got 72 men, but I'm going to work out a fraction. So 120 degrees out of 360 is the proportion of men that work at Porth. So if I multiply that by 72 and pop that into my calculator, I can see that gives me 24 men who work at Porth. So the probability that this person picked at random works at Porth, if we've got 32 females and 24 males who work at Porth, that means we've got 56 people who work at Porth. Now, it's 56 Porth employees out of a possible 200. And that's the probability. So the probability of Porth is equal to 56 out of 200. Question 14. PQR is a right-angled triangle. The length PR is 16.7 and the length QR is 9.6. It wants us to calculate the size of the angle QPR. So let me find that angle, QPR. So it's that angle I want to find the size of. Now, 2 sides and an angle straight away says to me trigonometry. So before I even start the question, I'm going to write out what I remember about trigonometry equations, and it's SOHCAHTOA. And then the pyramids, the sine of the angle is equal to the opposite length over the hypotenuse. The next triangle, the cos of the angle is equal to the adjacent angle over the hypotenuse. And finally, the tan of the angle is equal to the opposite over the adjacent side. Then I'm going to label the sides on my triangles. This is the hypotenuse. The side opposite the angle in question is the opposite. And then the other angle, the other side rather, is the adjacent. Now I can see involved in this relationship, we've got the opposite side, sorry, the hypotenuse and the opposite side. So I'm going to use the sine equation to find the angle. So I can say that the sine of angle QPR is equal to the opposite over the hypotenuse. So the opposite is 9.6 over the hypotenuse, which is 16.7. And if I plug that into my calculator, it gives me the number 0.5748. So the sine of the angle is that number 0.5748. To find the actual angle, we have to find the arc sine to the -1 of that number, which is 0.5748. And if you put that in your calculator, that actually gives you the angle of 35.1 degrees. So we can say that that angle QPR is 35.1 degrees. Question 15. There's a lot of words in this question, so I'm going to read it quite carefully. So the Morgan family and the Smith family are on holiday in Aberystwyth. There are 7 adults and 2 children in the Morgan family. There are 4 adults and 3 children in the Smith family. Both families visit a craft centre. The entry price to the craft centre is X number of pounds for adults and Y number of pounds for children. The total cost for the Morgan family is £41.50. The total cost for the Smith family, £29.75. First thing it asks us to do is form 2 equations in terms of X and Y, and then solve these equations using an algebraic method to find the entry price for adults and children. And I can see straight away it's simultaneous equations. But I'm going to start by forming 2 equations in terms of X and Y. So let's have a look at the Morgan family first. In the Morgan family, there are 7 adults and 2 children. The price for 1 adult is X number of pounds. So for 7 adults, it's 7X. There are 2 children in the family. The price for children is Y pounds. So if we add 2Y, 7X plus 2Y is how much it costs for the family to get in. And we know that is equal to £41.50 because we're told. Now, if we look at the Smith family and do the same, the price for the Smith family, there's 4 adults, so that's 4X, and there's 3 children, so that's 3Y, and we know that adds or equals 29.75. Now, to solve these equations, that means we want to find the value of X and Y. I'll just rub that out, and it was, I'll just make sure that's quite clear, £29.75. I'm going to label these equations 1 and 2, and that will help me when I'm solving them. So I want to, first of all, manipulate the equations just to get X in the equations. And the way I can manipulate it is I can multiply equation 1 by 3 and multiply equation 2 by 2. And if we do that, we'll have 6Y in both equations. So let's first of all multiply equation 1 by 3. So 3 times 7X is 21X. 3 times 2Y is 6Y. and 3 times £41.50 is £124.50. Now if we multiply the second equation by 2, 2 times 4x is 8x, 2 times 3y is 6y, and you can see we've got 6y now in both equations, is equal to 2 times 29.75 is 59.50. Now if I label these equations now 3 and 4, to get x on its own, I'm going to take equation 4 away from equation 3. So I'm going to write that down. Take equation 4 away from equation 3. So 21x minus 8x gives me 13x. 6y minus 6y is nothing. 124.50 less 59.50 is 65. So I can say that 13x is equal to 65. So therefore divide both sides by 13. So x is equal to 5. Now if I know x is equal to 5, I can substitute the value of x back in equation 1 to find the value of y. So substitute in 1 to find the value of y. So I'm going to substitute x equals 5 in that first equation. So 7 times 5 is 35 plus 2y is equal to £41.50. And then we just manipulate that equation, get a bit more space here. That means take 35 away from each side, so 2y is equal to £6.50. That means y is equal to £3.25 because I've divided both sides by 2. So the adult entry price X is £5 and the child entry price is £3.25. And that has completed that question. Question 16 asks us to find a solution to the equation, so find the value of X using trial and improvement. Now, in the last 5 years, there has always been a question on trial and improvement in the GCSE exam. So you should make sure you learn the method because it's almost a guaranteed 4 marks and it's almost guaranteed to appear. So the first thing we do is in the first column, we put the value of X that we're going to try. In the second column, we put the equation 2x cubed plus x minus 10, and we want that to equal to 0. And then in the third column, we put whether it's too big or too small. Now we know that the solution lies between 1 and 2, so I'm going to try 1.5. And if I put that into this equation, x equals 1.5, 2 times 1.5 cubed plus 1.5 minus 10. If we put all that into the calculator, you would see that the value of that comes to minus 1.75. Now we're looking for 0, so this one is actually too small. So minus 1.75 is too small. So that's too small. I'm going to try 1.7 because that's a bigger number. Put it into the calculator as I've done for the previous one. And the answer actually comes out at 1.562, which is too big. So that's too big. I'm going to try 1.6. Put that in the calculator and the answer comes out as minus 0.208, which is too small. So I can say 1.7 is too big, 1.6 is too small. I'm now going to try 1.65 because if that's too big, the answer will be rounded to 1.6. But if it's too small, the answer will be rounded to 1.7. So trying 1.65, the answer, putting it into the calculator, the answer is 0.634, which is too big. So if I look at my number line, I can say that 1.6 is too small, 1.7 is too big. When I've tried 1.65, I found it's too big. So any number less than 1.65 will round to 1.6 because the answer is going to be somewhere between 1.6 and 1.65. Whatever that number is, it will always round to 1.6. And the question asks us to find the solution correct to one decimal place. So the solution is that x is equal to 1.6. Coming on to question 17, it asks us when a number is reduced by 15%, the answer is 6154. What is the original number? Well, let's think about this for a minute. When a number is reduced by 15%, the answer is 6154. That means 85% of the original number is 6154. Now, if we let the original number be x, we can say that 85% of x, the original number, is 6154. So if we just kind of work that out to solve the equation to find the value of x. So 85% is 85 over 100 times by x is equal to 6154. So manipulating that, x is equal to 6154 multiplied by 100 divided by 85, which equals 7240. So the original number was 7240. Let's have a look at question 18. It tells us that ABC is a cyclic quadrilateral in a circle with centre 0. So cyclic quadrilateral means a four-sided shape inside a circle with each of the vertex touching the edge of the circle. So here A, B, C, D is a four-sided shape and each of the vertex touch the edge of the circle. That means it's a cyclic quadrilateral. It tells us that ABC is 126, so that angle ABC is 126. It asks us to write down the size of each of the angles x and y and give reasons for our answer. So let's start with angle x. Now angle x is opposite the 126, and it just so happens, using the circle theorem, which you have to learn if you want to get these questions right, opposite angles in a cyclic quadrilateral add to 180. So angle x is 180 less 126, which is 54 degrees. And the reason is opposite angles in a cyclic quadrilateral add to 180 degrees. Okay, so angle y, it wants us to find the size of angle y. Well, we've just found out the size of angle x, which is 54 degrees. Now angle x is 54 degrees. So using one of the circle theorem rules, we know that the angle at the center is twice the angle at the edge if the angles are subtended by the same chord. So we can say that angle y is 2 times 54, which is 108. And the reason is that the angle at the centre of the circle, which is angle Y in our case, is twice the angle on the circumference, which is 54 in our case. But just for future reference, they've got to be subtended by the same chord. And the chord is AC there. That's the answer to the question.